Hi folks, I'm using Ladybug to do the videos. Just this way it's under my document camera, a little bit easier for me to do. So we're going to start this new unit, the linear equations unit. The most important thing about equations is that they have equal signs. And the difference between this unit and the polynomial unit is that with equal signs we can solve. So x equals 2. X has a value of 2. So we'll be solving. So in the polynomial unit, what we did was we simplified or we combined like terms, but we never really could get it down to equaling something like a number. A letter equals a number. We can do that in equations. So that's what we're going to do. Lots of you will have done this in elementary school, so some of this might be a review for some of you, and others it might be brand new. So here's hoping it's something you've already done or that you find it really easy. I find once people catch on, it's not too terrible. So some things that I just want to review from the last unit, we're going to look at terms. So terms are parts of an expression that are separated. Oh, this is why I'm using an erasable pen. That are separated by the add or subtract sign. I'm just going to abbreviate there. Okay, so the next one is the constant. So the constant is just a number, no variable attached to it. And when I'm talking about variables, I'm talking about the letters, the unknowns. The coefficients are the number in front of the variable. And what they do is they tell us how many we have and whether they're positive or negative. So looking at this example here, what are my coefficients? Well, my coefficients are, that's supposed to say the number in front of the variables. So I have a 3 and I have a negative 6x. So my coefficients are 3 and negative 6. Now what's my constant? It's just the number by itself. So my constant is the number, no letter attached to it, so that's the plus 18. But you guys know all this because you did the polynomial unit and you did awesome at it. So in this lesson, we're just combining 1 and 2 step equations. So here's the thing, is that 1 step means you only have to perform one mathematical operation. That's why we call it 1 step. Okay, maybe that's better. You can add, subtract, multiply, or divide. Those are your 4 operations that you have. And when solving algebraic equations, our goal is to isolate, you'll hear me say this a lot, isolate the variable. So when we're isolating the variable, what that means is we're trying to get the letter alone on one side of the equation. It doesn't matter if it's left or right, but it needs to be alone. You must perform opposite operations. Okay. So just jumping over to this box. If I'm adding something, the opposite operation is to subtract it. If I'm multiplying something, the opposite operation is to divide it. And that's vice versa. So if I'm dividing something, opposite to not divide would be to multiply. So we need to know our opposite operations. All right. Sorry, just trying to slide the paper up here. Okay, so we're going to do some basic algebra. It's a little fuzzy on the sides. Wondering how it's going to turn out in the video. Okay, so I want to get t. Remember the goal is to isolate that variable. Isolate the variable. So I want to get t, that's the letter t right there. I want to get that one all by itself. So if t has plus 7 attached to it, the opposite operation to get rid of that 7 would be to subtract 7. because 7 minus 7 is 0. And then all of a sudden t is alone. But if I do a subtract 7 on this side, I have to do a subtract 7 on the other side. So I'm going to have t, and this goes to 0. So I don't have to write that. And then 21 minus 7 is 14. And that is my answer. One mathematical operation, pretty easy to do. So again, we are isolating the variable. We're trying to get that letter all by itself. So this one, same sort of thing. We want to get g by itself. But g has a subtract 6. So opposite to subtract is to add. So we are going to add 6. But if we add 6 to this side, think of an equal sign like a seesaw or a scale. You want to keep it level. So whatever you do to one side, you want to do the other. It would be really awful if I brought cupcakes in for half the class and didn't give them to the other half. So if we add 6 on this side, we have to add 6 on this side. So these, again, should go to 0. The whole goal of this is to get g by itself. So these should always just cancel each other out. So g is equal to 46. And again, one-step algebra, I'm only doing one mathematical operation. Now this one, 8n. So really what that means mathematically is 8 multiplied by n. Now we as mathematicians just don't write the multiply sign. We know if two brackets are next to each other, that means to multiply. If a number is in front of a variable, we also know that that means to multiply. So knowing that's an 8 times an n, the opposite operation to multiply is your divide. So we're going to divide this side by 8. And if we do it to the right-hand side, we have to do it to the left-hand side. So 8 divided by 8 is 1n, and negative 32 divided by 8 is a negative 4. Now, in math, we don't usually put the ones. That's something we usually don't see. So most times, you're going to see my answers like this. So there's no coefficient in front of it. And that's cool. We're mathematicians. We can go further, faster. And again, these should always be the same number. So if this was a negative 12, it would be you're dividing by a negative 12. You want to just get that single n, not a negative n, nothing like that. And if you notice my n is on the right-hand side, and over here my g was on the left-hand side, it does not matter. A lot of people like to see letters on the left-hand side only. I don't care. It's really your preference. Okay, so this one looks a little bit odd. It's a fraction, but really what this means is x divided by 7 equals negative 4. So x divided by 7, I don't want to divide by 7. I'm going to do the opposite operation. So I'm going to multiply because I want to get x by itself. So I'm going to multiply this side by 7. And I'm going to multiply this side by 7. Because whatever you do to one side, you always have to do to the other. Okay, I'm going to write down a step that you don't have to. This would be 7x over 7 equals negative 28. Okay, so remember fractions, straight across the top, straight across the bottom. What's on the bottom of this one? It's the number 1. So we're going to multiply straight across the top, straight across the bottom. So we get 7x over 7. We just did that right here, and we know that that leaves us with x. So you can go right from this step down to that step. You don't have to write that middle step. Write it if it helps you. Write it if it helps you remember, because that's important. Okay, the bottom of this. So now we have a negative 6, but remember this is negative 6 times by x equals 48. So if I'm timesing by a negative 6, that means I have to divide by a negative 6. And I have to divide both sides. So x will be equal to a negative 8. And this is a really, the math on this is pretty simple, but it's really easy to make a mistake for getting a negative sign. So pay attention to that. Okay, this one looks a little bit different. So we have negative 4 plus g. That looks a little bit different. What if I wrote it like this? Because then you're like, do I add? Because it's a negative, or do I subtract because I'm adding? It gets very confusing. What if I rewrote it like that? Doesn't that mean the same thing? It really does, because my 4 is negative here, my 4 is negative here, my g is positive, my g is positive. It's just a different way of looking at it. I'm just going to flop back to the first way it's written there. And what I'm going to do is, this is a positive g, so I'm just going to leave that alone for right now. I'm going to look at this negative 4. What's the opposite to negative 4? I want it to get it to 0. I'm going to add a 4 to it. I'm going to add a 4 to this side. So my positive g equals 11. And you can do it either way. So rewriting it makes more sense to you, go ahead. Sometimes it's easier to see. And so same thing here. I have a negative 8. What if I flip these around? It's a positive x and it's a positive 15. Sometimes people see it easier when the letter comes first. It really doesn't matter. If you don't need to see it, if you need to see it, but if you can see it without switching it around, then you're doing great. So I'm going to subtract 15 from this side. I have to subtract 15 from this side. So x is equal to a negative 23. Okay, so that's one step. Easy peasy, you can probably do it in your sleep. Hopefully. I'll pause for a second, make sure you get all those notes copied down. We're rolling right into two-step. I find that doing one and two-step at the same time is just a little bit nicer. The one-steps people get really quickly. The two-step, really easy too. So I like to combine those together. All right, so moving that page over. All right, where am I? Okay. Solving two-step equations. So in a two-step equation, you'll have to perform where's my highlighter? Two mathematical operations this time, hence the name two-step. And you're going to be shocked, but three-step is 3 mathematical operations. Okay, so this is what I like to call it. I like calling it undoing BEDMAS, because we know that we have to do it brackets, exponents, dividing, multiplying, add, subtract. But we are trying to undo the math that was done. So we end up having to start from the bottom and go up. So the first thing I undo is either my add or subtract. Okay? So you're undoing it. Think of a zipper. If you've zippered your jacket all the way up to your chin, where do you start when you want to unzipper your jacket? You start at your chin and unzipper it to your waist. So we're going to do BEDMAS backwards. Sounds complicated, but it's not. Start at the bottom, add, subtract. So when I look at this example, the first thing I'm going to do is I'm going to get that variable by itself. Well, it's got a 3 in front of it. Not the end of the world, but we want to get this by itself. So I'm going to add 8 to both sides because I'm dealing with my add or subtract, and this was a subtract 8, so I'm going to add 8. So I have 3a equals 12, and we know that the 3a really means 3 times a, so the opposite, let me write that off to the side, put an arrow there, looks like a colon, geez Louise. So the opposite to multiply is divide, so I'm going to divide this side by 3, divide this side by 3. So I'll be left with 1a equals 4. And again, I don't have to write down the 1. If you write down the 1, it is okay. It's just as you get better at this, you're going to want to do it faster. Okay, so the first thing I'm going to do with this one is I do my add subtract. I'm going to keep pointing to this corner over here. I'm going to do my add subtract. So if it was an add 2, I minus 2. Lots of people ask me, how do I know what side to start on? And you always want to start on the side with the letter, okay? So start on the side with the letter. Okay, so now I have minus 2 from both sides, so I'm left with z divided by 6 and 24. Okay, so next I'm moving up to my divide multiply, so I want to get rid of a divide by 6. So that means I'm going to multiply this side by 6 And I'm going to multiply this side by 6. So these will cancel each other out, leaving me with just Z. And I always cross my Z's so they don't look like 2's. And if I were to do 6 times 24, I'm going to get a whopping 144. That's a dozen dozens, just in case you're wondering. Okay, so going over here again, I start with the add subtract, and I always start on the side with the letter. So I'm going to add 10 to both sides. So I have 25 equals m divided by 5. And again, opposite, so now we move up to the divide multiply. So opposite operation to divide is multiply. I have to multiply both sides by 5 because I want to get rid of that. That's the most important thing. So I get a single variable. So I have 1m because 5 divided by 5 is 1, but I'm not going to write the 1. And 5 times 25 is 125. It's pretty exciting stuff, I know. All right, moving up. I'm going to try to get through these a little bit faster. Okay, so this is a weird one. That 5's by itself, but I know that 5 is positive. So the opposite operation to a positive 5 is to subtract 5. So I'm going to subtract 5 from both sides. Now, on this side, I'm left with a negative 7t. That's okay. Just make sure you don't lose that negative. All right, so now the operation here, I'm just going to write this off to the side. So this would be negative 7 times t. It's not an add, it's a multiply by a negative number. So we're going to divide by a negative number. Divide by a negative number. So negative 7 divided by negative 7 is a positive 1. And this will leave me with a negative 5. All right, so here, again, a weird one. It's starting with the constant. So it's a minus 6, so I'm going to add 6. Notice I'm interchanging the words minus, subtract, and negative. They really all, like, what it is it's showing that you're removing something. So I'm interchanging those. So I hope you guys are okay with that. So 96 equals, and this is a positive 12, so 12x. Those are multiplied together, so I'm going to undo them by dividing. That is 8. Oh, I haven't boxed in any of my other answers except I decided to do this one. Okay, so this is another one, little bit same sort of thing. That constant is leading there, that 14. So I'm going to subtract 14 from both sides. So I'm going to be left with c divided by 3 equals, okay, so I have 8 subtract 14, so that's going to leave me with a negative 6. Okay, I want to get rid of the divide by 3. So remember, I'm always working on the side with the letter. That's the one that's going to direct me what math I need to undo. Okay, that's the most important part. Slide it a little bit forward again. Now we're down to our last ones. All right. Ooh, we've never seen this one before. You're like, what do? I've got 2 m's. I've been moving constants around. So this one's really interesting. This is kind of a lead into 3-step, which is exciting. So this one, what I'm going to do is I'm going to get rid of this from this side. Whoa. Oof. Okay, let's do this. So if it's a plus 7m, I'm going to use the same principles. I'm going to subtract 7m. But if I subtract 7m from this side, I have to subtract 7m from that side. All right, so those are gone. That gives me 0. So I'm left with a negative 16 on this side. And when we collect like terms, so this is our helping of the polynomial unit. So positive 5 minus 7 is going to give me a negative 2m. And now this is just a one-step algebra question. So in this case, instead of getting all my constants to one side, because in these equations, I had a constant and a constant, I had a constant and a constant, and then this example, I've got a coefficient and a variable and a coefficient and a variable, so a little bit different. Math still stays the same. That's what I like, I think, most about math, is that the rules stay the same. I can apply them, and I should always be doing them the same way. Helps keep things consistent. So it was multiply by a -2. That's similar to this question that we did. Ooh, can't see it. Similar to this question that we did up here. So it's multiplied by a -2, so I'm dividing by a -2. So I get a positive 8 as an answer. Okay, last one. Ooh. Okay, so I'm going to add 4 to both sides. Okay, so I get 21 equals, my x now is negative. And we know that if there's no number in front of the variable, we know it's that invisible number 1. So I'm going to actually put that invisible number 1 in there because I think it's going to help. So I don't want a negative x, I just want positive x. So I'm going to divide by a -1, divide by a -1. So that leaves me with a positive x on this side and a -21 on that side. And that, ladies and gentlemen, is your 1 and 2 step. I hope that was helpful for you, and let me know if you have any questions. Thanks.